Today's objective, squares and square roots. Let's go over some definitions first. Perfect square, the square of a whole number. For example, 3 squared, which means 3 times 3 is 9. The number 9 is what we would call a perfect square. Square root, a number that when multiplied by itself equals the given number. The symbol for the square root is a sign. It's also known as the radical. So an example, the square root of 9, and that equals 3 because of 3 times 3. Vic number 1. Every positive number has 2 square roots, 1 positive and 1 negative. So let's look at the square root of 16. Square root of 16 equals 4, since 4 squared is 16. 4 times 4. Same thing also goes that the square root of 16 also equals negative 4, because when you square negative 4 times negative 4 is also 16. The positive square root is also called the principal square root. Perfect squares. There's 3 different ways in order to write these, okay? When we look at it in this format, the principal square root, that's always a positive one. So the square root of 16 equals 4. The default of taking both square roots is you also know that there's a positive and a negative outcome. But typically, by default, we always use the principal square, which is the positive number to it. And then here, when you have a negative on the outside, when you take the square root of 16, that would equal negative 4. So that would be the opposite of that. Okay? So let's look at some examples. So the square root of 36, remember by default there's a positive and negative already out there. So we know that there are 2 roots to the square root of 36, which is positive 6 and negative 6. And let's look at example 2. Notice I have a fraction here. But when I take the square root of 25 over 4, we're going to break the radical up between the numerator and the denominator. And notice that the square root of 25 is 5, and the square root of 4 is, sorry about that, is 2. So as you can see, they're both at square root, so we just separate it and we simplify it that way. So let's look at the square root of, we have negative square root of 9. So remember, the negative would come with it, and so the square root of 9 would be 3. So this is the negative form, the opposite form of our principal square root. So here, you can have decimals in here, and so the square root of 1.69 equals 1.3, because 1.3 times 1.3 is 1.69. Not all square roots are perfect squares. Some are even irrational numbers. So let's take, for instance, the square root of 5. If I would actually type that in my calculator, this is what I would get. And remember, irrationals, they don't stop, they keep going. All right? In these cases, you will need to identify what 2 integers the square root falls between. So this would be your first step as far as approaching these problems. So for example, the square root of 14.52, that falls between which 2 consecutive integers? So think of mine, think of the number line. All right? So the square root of 9 is 3, and notice that that is before square root of 14.52. And then one above that is the square root of 16. So when you look at them with the radicals, and they simplify, square root of 9 becomes 3, square root of 16 becomes 4, and we know that that falls in between those 2 integers, okay, consecutive integers. We're not sure what that is, but we know it's between them 2. So let's practice. What 2 integers does the square root of 22 fall between? So again, I'm thinking some perfect squares. I know that the square root of 16 and the square root of 25, because that gives me that it's going to be between 4 and 5. in radical form, it does fit in between these numbers, so I know I'm on the right track there. All right, so therefore the square root of 22 is between 4 and 5.